Hello everyone, welcome back to my channel. My name is Piyush and this is video number 27 in the series CK 2024. And in this video, we'll be setting up a Kubernetes cluster, a multi-node Kubernetes cluster on virtual machines, and we'll be doing with the help of Kubeadm administrative tool. So this is one of the important tasks for any Kubernetes administrator, and that is what I'm gonna do now. It'll be a complete hands-on video, so I will explain you the steps and the nitty-gritty of it at the very beginning, and then we'll do the hands-on from scratch. And yes, there'll be some task in the GitHub repository. Make sure you attempt that and make sure you try to do that on your own so that you are aware of all the steps. And if you face any issues, then yes, let me know in the comments and in the Discord community, and we'll help you out. So yeah, without wasting any time, let's start with the video. So let's quickly have a look what are the different type of installation that we can do with the help of Kubernetes. So let's quickly have a look first how we can install Kubernetes in multiple ways based on our requirements. So this is not an exhaustive list, but this will give you some idea, right? So first we have to identify our purpose, like why do we need Kubernetes? Why are we installing it? Right, if we are doing it for any local setup or for any POC, or if we want to test something out very quickly on our local environment, then we'll go with these options like kind, which we have already done, which we were using till now, or I guess it's K3s, right? And then Minikube, and there are other options as well. So it will install your Kubernetes cluster on your local machine that you are working on, and it will either use a virtualization technique, or it will spin up containers that will act as node, and so on. So this is a quick setup in which you don't have to do a lot of things. You don't have to install any component. You just install the utility and it will take care of the rest, right? So this is sort of a self-managed service, but it does not have a lot of steps to perform, and it is quick and easy to set up. But this is not for your production environment, and this is not meant to be used in your organization, right? Because of many limitations that it has, and it's not really a highly available cluster because it is running on one node, right? You only have one virtual machines as your local machine, and it is splitting that into multiple machines or multiple nodes. So that is why it is not recommended for non POC or non local use. Now, let's say if you are not have the requirement of doing a POC or the local setup, and you have actually have to use it in your organization or as a production server or even a non-prod server, then the next question you should ask is if you need a self-managed service or a managed service. Self-managed service means you don't really take overhead of control plane components, like your all the control plane components, your API server, controller manager, HCD, your kube scheduler. Every control plane component is managed by a cloud provider or a service provider. It's not managed by you. So in that case, you go with the managed Kubernetes service on cloud, such as EKS, Elastic Kubernetes Service on AWS, AKS, which is Azure Kubernetes Service, and GKE, which is Google Kubernetes Engine. You can go with these options. But if you want to manage everything by your own, including all the control plane components, including the control plane node and node maintenance and everything, including patching, upgrading, and everything else, then you go with these options. So we have Vagrant or virtual machine. You can set it up on your virtual machine using Vagrant on VirtualBox. Again, this is not for production environment because ideally you are running it on one single host underneath, right? But if it is managed at a data center and it is highly available, then you can use that. Then if you are using it on Mac silicon chip, then VirtualBox or Vagrant would not support as much. Like there is a limited support for that. For that, you can use multipass. So here is the documentation for that. You can install multipass and download for Mac OS, and then you can run basic steps like multipass list to list all the instances, launch to launch the virtual machines. Let's say you can launch multiple Ubuntu machines on your local setup, and so on. So there are different commands that you can do that. So that's one option. Another is to spin up your virtual machines on cloud. You can choose any cloud provider, and you can basically spin up virtual machines and use those virtual machines as separate nodes on the cloud, so that it will be on multiple hosts, and you can basically create a cluster out of it manually. Then you can use some other managed services on bare metal and VMware, right? So in this video, I was earlier using multipass. I set it up everything using multipass to test it out, but it has some requirement, like you should have at least 2 GB of memory and two vCPUs for each node, and I don't have enough space available on my system. That is why I have dropped that idea. But you can use that if you have at least 16 GB of memory available in your Mac, and it works well with Mac M2. I have tested this on M2. It works well, considering if you have enough memory. But it works on other Mac Intel chip as well. It works on Windows, Linux, and everything else. So this is good. You can try it out. In this video, we'll be doing it on VMs on cloud. And it doesn't matter which cloud you are choosing. You can go with AWS, Azure, GKE, or you can set it up on any other virtual private servers like DigitalOcean. Any credits that you have that you want to use, or Oracle Cloud, for instance, you can use that. We basically need three virtual machines, one which will act as a control plane node, and two which will act as the worker node. So that's what we need, and that's what we are going to do, right? So I'll, because I have some AWS credits, so I'll be using AWS, but this is not AWS specific video. So I will skip the part around AWS setup, AWS specific setup, and I will just explain you everything, right? For example, I have created the security groups, right? And I will explain you why we are creating all the security groups and why we need it. But I will spin up the instances and I will start from there. Okay. So let's start with the demo. Okay. And here are the different steps that we'll be taking. Okay. So this is what we are going to do. Basically, what we need is we need three virtual machines on cloud, right? One for master, two for worker nodes. Then we have to open certain ports for control plane and other components. Like, you don't have to remember which port to open, but here is the document. Okay, and it's there in the same document, kubernetes.io/docs. And if you can search ports and protocols, you will find this document. It will show you what ports should be open for control plane and what ports should be open for worker nodes. If you want to have a look in a deeper level, here is the diagram in which I have specified what all ports we need. So let's say you are an admin, okay, and you need access to Kube API server, right? And which is accessible on port 6443. So you have to open that port. Then your kubelet will be accessible on port 10250 on both the nodes. And then your kube proxy will be accessible on 10256 on worker nodes. And on control plane, you have to open ports for each of the control plane component, like scheduler 10259, but it receives the request internally from the control plane only from Kube API server. So you don't have to make it accessible to outside the world. Same with controller manager, same with HCD. For HCD, we have to open two ports, one for client, one for server. And again, HCD is only accessible from API server. So you have to only limit the access within your VPC or within your virtual private network. You don't have to open it to outside the world. Then your application will be listening on high-end ports from 30,000 to 32767. Like when we use a service or when we use a load balancer to expose our application externally. So that is why we have to open these ports as well on the worker nodes. And we have to open SSH port for the admin. Like, I am the admin for this cluster, so I will open the SSH port on worker node and control plane node on port 22, right? So that's all about the ports, and all the information are here as well, right? So that's what we're going to do. After that, after we open the ports, here we are. So we have to execute certain steps. We have to install certain utilities on both the nodes, on all the nodes, on worker nodes as well and on the master nodes. On master node, and worker nodes. So let me give you a brief of all the steps that are common in all the nodes. So first we'll start with disabling the swap on all the nodes. Then we'll update kernel parameters. We'll install container runtime, runc, and CNI plugin. So there is a separate video in which I have discussed the difference between container runtime and runc. So have a look at that if you're not aware of it. Then we'll install CNI plugins, and then we'll install the utilities. So Kubeadm will be the utility that will be helpful in administering the cluster, like installation, upgrade, update, delete, and so on. So Kubeadm, as the name suggests, Kubeadm. So it will be the utility that takes care of your cluster administrative task, right? And then we have kubelet, kubectl. We are already aware about all those things. And then on the control plane node, on the master node, we'll initialize the control plane using Kubeadm. So what we are doing, we are telling that you are the master. So act as a master, right? Using Kubeadm init command, we are actually giving that role to the control plane node that you are the master node. Because what we are doing, we are spinning up 3 virtual machines. So how would it know like which one is the master node and what all are the worker nodes? So we have to specify that using Kubeadm init command on the master node. And then we'll install CNI such as Calico, Cilium, or anything else that you want to install. Right. So this, as I've mentioned before, this does not come with the Kubernetes installation. This is a network add-on that you have to install by yourself. Okay, and once that is done, once you have initialized your control plane using Kubeadm init command, so you have instructed that yes, you are the master. Now, who are the workers? How do we know? So when you run this command, it will generate an output for you, and in that output there'll be a token. So using that token, you have to run that on the worker nodes, and basically you are joining the worker nodes with the master. So you will run the command such as kubeadm join master and pass the token over here, and this has to be run on the worker node, and then it will join the master as worker, and then you will be able to run your workload, run anything else, and so on, right? So these are the high level overview of the steps that will be executing. So first, let's start with setting up the VM and opening the control plane ports and other components. Right now, I'm here in my AWS console. As I've mentioned, you can use any cloud provider of your choice, or you can use multipass to spin up the virtual machine. So that step is common. You can spin up your virtual machines on any platform, any step. It doesn't matter for this demo, right? Because we'll be focusing mostly on kubeadm and installing all the other components of Kubernetes. So I have created a security group for all the virtual machines. So I've created 2 groups, one for control plane and one for worker nodes. Like this works the same way in any other cloud. So if you are using Azure, you will be creating NSGs or network security groups. If you are using GCP, then you will be creating firewall rules. But it works the same way. You actually allow or deny certain type of traffic on certain port from certain source and destination, right? So that's what we are doing. So if we look at our control plane rule, so let's see. The first rule is custom TCP on port 10248 to 10260, right? So these are all the ports that are used by control plane components. We have specified the port range and the sources. I'm sure it is visible, but if it's not visible, the source is 172.31.0.0/16, which is the CIDR range of our VPC. So that means these ports are open for any traffic that is coming within the VPC. And within the VPC, that means all our control plane components are running in that VPC. All our worker nodes, master nodes are running on that VPC. So that is the source that we are allowing the traffic from. Then we have 2379 to 2380. That is for HCD. Again, the source is same within our VPC. Then we are allowing SSH traffic on port 22 for our admin. So that's my IP, the IP of the machine that I'm using, so that only I have the access to SSH into the virtual machine. And then 6443 for API server, again for the entire VPC. So that's the control plane security group. And if we look at the worker node security group, here it is. So in that, again, we are specifying 10256, okay, 30,000 to 32767 for high port range, and 10256 is for kube proxy that is running on worker nodes. Port 22 access to my IP so that I can SSH into the worker nodes, and 10250, this is for your kubelet API, right? So once you are familiar with this, once you start working on this, you will also remember these ports. But for now you don't have to remember it, everything is mentioned over here. It just worker nodes does not mention, and this node also does not mention port 22 exits. I'm not sure why they did not include that in the documentation, because to set up any virtual machine, or to set up any node in a Kubernetes cluster, you have to first SSH into that, right? So I'm not sure why they did not specify it, but yes, you definitely need that rule. Okay. So once we have the security group created, the next is to launch the instances. So I am on my EC2 console and I'm going to click on launch instances, give it a name. Let's call it master node. Okay. Select the OS image, and these steps are same for any cloud, whichever you are using, right? So you need a name, you need a base image, let's use Ubuntu, and then you need a virtual machine. So I'm gonna use, let's say, T2 medium, because we need to have at least 2 GB of memory or 2 vCPUs. So it's good. But you can select the smaller virtual machine as well. If it is working fine, then yeah, you can choose that. But don't go with T2 micro. I guess T2 micro should also be good. It has 1 vCPU, 1 gigabytes of memory. So you can try that and let me know if it is working fine for you. But for now, I'm going to use T2 medium. Okay. And you actually use a key pair to log in, or you can generate your own key pair. So I already have one. I'm just going to use that. And over here, you select the existing group. The group is control plane. That's what I'm going to use. And let's leave everything as default and hit on launch instances. So this is our control plane node. And now we need two more worker nodes, and those can be identical, right? So I'm going to click again on launch instances and just name it worker. Okay, and number of instances is 2. And again, select the Ubuntu image, and let's select T2 medium. Yeah, this machine can also be small because control plane needs more memory and more CPU. This can be a smaller as well. So key pair CK 2024, and let's use the existing security group. And this time I'm going to use worker node, and rest everything is default. Hit launch instances. So if you go to instances and hit refresh, our control plane is running. Those two are still coming up. So let's change the name and let's give it worker 01, and let's call it worker 02. Okay. So now we have, okay, this is also running, should be up and running. So now we have 3 EC2 instances up and running. So now let's log into the control plane node, and then we'll execute the rest of the steps. So if we go back, this is done. Now we'll proceed with disabling the swap. So I already have the steps documented in my local editor, but I will be sharing everything. So no, not these ones. Okay, just give me a second. Okay, over here, right? So I will be sharing everything in the GitHub repository, and I will also create a blog out of it so that you will have the step-by-step instructions. So yeah. And this is based on the latest installation of 1.30, because I was following the blogs and the documentation from the earlier setup, and some of them are outdated. So make sure you use the latest images for container runtime, for runc, for other components as well that we are using. And this is what I have already tried and tested. So this should work fine for 1.30 and any of the latest versions, right? So we'll start with this disabling the swap. Okay, and then forwarding IPv4, and basically tuning the kernel parameters. But for that, we have to first do the SSH. So let me just open the terminal window. Okay, you can use Putty or any other client that you have. I think should be visible now. Let's grab the command to SSH. Let's use this. Go to the instance and hit connect. Then the command will be generated for you. Copy the command. And if we go back, currently I'm in this directory. So I have to go to downloads because there is my PEM file, the key that I generated. So now I can run the command and ask for authentication. Yes. And that's it. So I am inside the virtual machine. I'm inside the control plane node. And now let me open one more terminal. Actually, let's proceed with the control plane first, and then we'll move on to the worker nodes. Okay. So let's start with the first step, which is disabling the swap. I'm going to run these two commands. Okay. And then I'm going to run these commands to update the kernel parameters. So you can read more about it, what they actually do. But for now, I'm just executing these commands, and make sure these three fields at the very end, the value should be 1. If it is correctly set, then we are good to proceed further. These should be 1. And then after that, we are installing container runtime using the latest image of container D. So container runtime, again, we can use any of the supported container runtime. Please be advised that Docker used to be one of the container runtime supported by Kubernetes, but after Kubernetes 1.24, that has been removed, and the default container runtime is container D with any of the managed service as well. So this is what I'm gonna use. Okay, so let's download the binary. So here is the latest binary 1.7.4. It should be downloaded over here. Okay, here it is. And then I'm gonna just untar it to user slash local directory. Okay, it has these many binary files. And then I'm gonna run container D as a systemctl service. Okay, so I'll just download the service file as well. And basically you execute these steps. What it will do is it is visible, right? Yeah. So what it will do, it will create a directory inside systemd, and then it will move that service file to that directory. It will create another directory, and it will generate a config.tuml, which is a configuration file for containerd, and it will make some changes to basically update the system C group parameter from false to true, right? So that's what it is doing. And I'm going to execute all these commands, right? If you get any error, then you have to troubleshoot it, why it is there. But seems everything is good for now. And then you run sudo systemctl daemon reload. So if you are not aware about systemctl, read more about it. Like, it will be there in the documentation. And basically we are running a container D as a service. We are not running it as a container or as a pod. We are running it as a service on the system. So every time a system reboots, every time the virtual machine reboots, with this command, daemon reload or systemctl enable, with the help of this command, the service will start automatically, right? So that's what we are using, and it created some symbolic links as well. That's okay. And now you can check the status of systemctl service. With the help of systemctl service, if container D is up and running, and it says active and it is running. Okay. So our container runtime is installed. Then next is to install runc. So again, we're gonna download the binaries, and this is one of the latest. Then I'm gonna install runc with this command. Okay, and then I'm gonna install CNI plugins. So here is the curl command to download the binaries, and then we'll basically untar it. Okay, it has these many files, so it's untarred successfully. Now the next is to install Kubeadm, kubelet, and kubectl. So all the utilities and everything will be executed and installed with the help of this command. And over here, I'm using the latest binary 1.30 for all of these so that it is compatible with the Kubernetes version. So if you, let's say, if you are using control plane 1.30, and if we are using kubectl or kubelet as 1.28 or 26, sometimes there'll be issues. So it is a good idea to stick with the version of Kubernetes, right? So that's why I'm using 1.30. Okay, it's gonna take some time, maybe few seconds, and once that is done, you can execute these commands to verify the versions, and it will basically show you that if it's been installed successfully or not. Okay, so I'm just gonna copy this command while it is installing it. Okay, it says unpacking Kubeadm, kubectl, unpacking kubelet, and this should be done now. All right, doesn't show any error, so this should be okay. Now let me run these commands, and now it is showing me kubelet version is 1.30. Then we have this is the version of, okay, wait. First is Kubeadm version 1.30. Then we have kubelet version 1.30, and then we have client version. This client version is the kubectl client, which is 1.30.2, same as all the other three. Then we have to use this command to configure CRI-CTL to work with containerd. So CRI-CTL is a client for containerd. For example, Docker is the client for running Docker containers, right? So if we were using Docker, we were using Docker PS to check the status of all the running containers or Docker commands, right? Over here, because we are using containerd as the runtime, we'll be using CRI-CTL client. So CRI-CTL PS. This will show you, currently it's not running, but this will show you all the running containers, and PS CRI-CTL PS-A for all the exited container as well. And basically you can use CRI-CTL pull image, push image, the same commands that you would use with the Docker client, right? So we'll see that later on. But for now, like, I just wanted to let you know that CRI-CTL, why we are using it. And then basically you initialize your control plane node, right? Over here, you will set the API server address, and this should be your public IP of the control plane node. So this is 172.31.71 and 210, right? So this is the IP address of this, and then you're giving this node name as master, and this is your pod network CIDR. So keep everything and just execute this command. So now we are doing Kubeadm init. We are actually telling this machine to behave as a master. You are the master, so act as a master. And once that is done, okay, it says this is a warning that you can ignore. It is doing some pre-flight checks. So it is doing some validation. Those validations are called pre-flight checks, and it will check if everything is good. If your prerequisite and every setup is done, if everything is done, then it will proceed further with executing the command. So now it is doing the setup. It is installing the control plane component. See, it generated the static pod manifest over here. So config map, creating RBACs, the default RBACs, creating kubelet, and here it was, okay, here it was creating static pod manifest for API server, controller manager, scheduler, and so on. So it has installed all the control plane components, generated all the default objects, including the RBACs, and at the end, it is done, and it will show you the Kubeadm join token. So this is the token that we will be executing on the worker nodes to join with the master. So it has a command Kubeadm join, then the API server address. I mentioned that API server will be listening on port 6443. So that is what it is saying. And then a unique token with the token CSR, right? So I'm going to copy this command. Okay, and it generated this command as well. To start using cluster, you need to execute these commands as well. So first, let me copy the token. Okay, and I'm gonna paste it. Oh, let me paste it at the end. Okay, And if somehow, let's say, you miss to copy it, and if you forget it, so you can also generate the token using this command. A new token will be generated, Kubeadm token create print join. Okay, and for now we'll run this command. I will show you what it will do. So but let me just run this commands. Okay, what these commands will do, it will first create a directory, okay, inside your home directory, and call it .cube, and inside that it will copy the admin.conf. This is the default kube config file, and it will make this as your default kube config by copying that in .cube directory. Because if you remember the kube config video, I have told you that the default kube config file will be generated inside your home directory inside .cube folder. So that is what it is doing, and it is giving the permission to that file. So now if you are running kubectl get nodes, it is running your newly generated kube config file, and the node is created. The node is initialized with version 1.30.2, and the role is control plane because that's what we want it to be, and the status is not ready because we have not really installed the Calico or any other network pod network plugin. So for that, let's install Calico on master node. Okay, so I'm gonna copy these commands. Okay, it is also taking the latest binary of Calico, and it will create a lot of objects, and after that your Calico should be up and running. Okay, it says it's been created. Now if we do kubectl get pods hyphen capital A to all the pods, it's not ready yet, but our operator is ready. Tigra operator is for Calico, and it should be coming up shortly. And once that is up, your core DNS pod will also be up. Okay, so you can add hyphen watch to it to keep monitoring the progress, and it will show you that. And yeah, let me pause the video and I will come back once it is done. Okay, so looks like even after waiting for a long time, the status is not getting changed. It's still not coming up, and I see core DNS pods are stuck in container creating state, and I don't see any Calico pods over here. So there might be something wrong. So let's troubleshoot. So we have this Tigera operator which is responsible for provisioning Calico pods. So let's have a look at logs of this pod. So I have copied the pod name, and now let's run kubectl logs, the pod name, and then the namespace name. So namespace is Trigera operator or Calico operator. Let's see. I guess it was Trigera operator. Okay, no. Kubectl get namespace Tigera hyphen operator. Okay, I have spelled it wrong. So let's use this Tigera. Okay. So I do see some errors. Let's see. It says reconcile error. And here is the error. Could not resolve Calico network IP pool and Kubeadm configuration. So IP pool 192.168.0.0/16 is not within the platform configured pod network CIDR. All right. I know the issue is now. So it says the IP range that we have used, if you remember the command that we run to initialize the control plane, we initialized the pod network CIDR range as 10.244.0.0. But by default, Calico uses a different IP range, which is 192.168.0.0. So there is a mismatch of IP range. We have instructed Kubeadm to provision all the pods within this network range, and Calico is configured with a different network range. So we have to make the changes either over here in the pod network range or in the Calico operators YAML. So let's make the change over here. Let's make it 192.168.0.0/16. And like we cannot run the command directly again because we have already initialized the control plane. So to clean up everything, we have to do something called Kubeadm reset. Right, so sudo Kubeadm reset. This will reset the control plane. It will uninstall all the control plane components, and it will unregister the master as the control plane node. So let's run this. Are you sure you want to proceed? Yes. And it says it is unmounting everything, stopping everything, and basically removing everything. So you still have the kubeadm config file. So you can remove it manually or leave it as it is because we can overwrite it, right? So let's clear the screen and let's run the updated command now with the different pod network CIDR range. Okay, now it will do the task again. It will install all the certificates, all the pods, create static pods for all the control plane components, and it will basically create the kube config again, right? So let's run this command to update the kubeconf with the newly updated kubeconf. Let's override this and what else? Okay, I'll just copy the token command over here and I'll paste it. Now let's install the Calico operator again. Okay, it's created. Now let's run kubectl get pods hyphen a, and now we see our pods are in init state or pending state. So let's watch this. Okay, container creating, some are running, it's working now. So yeah, I guess that was the issue and we fixed that by updating the command. So you don't have to worry, I've already fixed it, and you don't have to worry because I will already provide you the updated commands. And with that, you also know how do we do kubeadm reset if there is a mistake, if you have to clean up everything and basically start everything from scratch. So that's how you do it. And yeah, it is running. It should be, everything should be running now. So we have one on one. Yeah, everything is running, everything is up and ready. So if we do kubectl get nodes, I see my control plane node is ready status and age is 100 seconds. So it just been restarted and it is now ready. So the work of control plane initialization is done. Now we have to basically perform the same step in all the worker nodes. We have two worker nodes. So I'm going to run similar steps in all the worker nodes and I'm going to pause the video, or maybe I'll just do it. I would not explain much because I've already explained it. So I'll just run the commands and you can follow along. Okay, so now let's go ahead with the worker nodes installation of all the utilities and all the steps that we have performed in the master node, except the one with the initializing the master control plane, because that has to be run only on the master node. Okay, so let's go back to our EC2 console where I have my machines running. So I'm gonna take the IP of worker node 1, like I need public IP to SSH into the instance, or I can just go in the connect section and copy the entire command along with the key file and everything. So it should be inside SSH client, and here's the command. Okay, and let's go back. Okay, so I'm open a new tab. Okay, I'm gonna source the bash profile. In fact, let me change it a little bit. Let me do PS1 so that because I'll have multiple terminals open at the same time. So it'll be better if we could just name the terminal as the node name, right? So let me enter this one. I think this should be the command, but let's try. So it should be worker one. Yeah. Okay. So this is our worker one node, and over here, this one equal to this is our master node. Okay. So this is worker one. Oh, I have to do that inside the terminal. So let me SSH first. Okay, it says permission denied, maybe because I'm not in the current directory. So downloads and then SSH. Okay, I'm inside my machine, the worker node. And now let's run that ps1 command again. Worker 01. Okay, now we know the difference between both the terminals. This is master node, this is worker node. Okay, now this is the new machine. We have not installed anything on this yet. So let's go ahead with the steps. I'll start with disabling the swap. So let me copy this command. Let's change the kernel parameters now. Okay, it should be till here. All right, it's done. Then installing the container runtime. So I'll copy the entire thing. Okay, if there is any error, if there are any issue, then we can run the commands one by one to see um, where the issue is. But seems like it worked. And now status container D is up and running. Now we can install run C. Okay, it's installed. Let's install CNI plugin now. And after that, I'll install the clients and the utilities, Kubeadm, kubectl, kubelet, and so on. So let's install this. Okay, and after that, I'll be running these commands to verify the version. It says the file, yes, overwrite. Okay, let's run the version commands. So 1.30.0 and 1.30.2. That's good. Now configure CRI-CTL to work with container D. Let's run this command. And let's verify if we are able to run CTL command or not. So CRI-CTL PS, if I do, it says unavailable. So it seems to be an issue with the sock file. So let's provide this permission from sudo chmod 775 on this file. Okay. Now, if we run the command again, it's still throwing the error. Or if we run this command from sudo, yeah, it is returning the results. That means there is some another file which this is referring and it is not able to find the correct permission on that. Currently, we assigned the permission or where run container d sock. So let's go inside this directory where run container d and let's see what all files do we have. So let's do a sudo ls-lrt. We have container d.sock and I guess this is the directory permission that it was throwing the error for. So let's do this. Chmod. Let's provide the permission recursively to this directory. Mode -r 775 to the entire directory. And let's see if that fixes our issue. There were only a few files. Why it is taking so much time? Okay, so this one is a directory run C and this one is also a directory and then there is another directory. Okay, maybe that's why. Okay, once that is done, we don't have to run the initialize control plane. What we need, and we don't need to install Calico as well because this is the network add-on that have already been installed on the control plane node. So what we'll do, we'll run this command directly, kubectl join. Okay, it's taking too much of time. Let's cancel this. Yeah, it's okay. We'll see that later on. But with the sudo, we are able to run this command. CRI CTL PS, all the running containers, right? So we have kube scheduler, kube controller, API server, like everything. And this is from the master node. Now, if I run this command, join, okay, it says it's not running as the privileged user. So I have to add sudo in front of it. Okay, now let's run this again. Okay, it says the file already available and this is already exist. have I logged into the correct machine? Oh, this is, I did a mistake actually. So if I do host name hyphen I 172.31.71.210, and if I do host name hyphen I, I I actually I took the IP of the wrong machine, because earlier when I logged into the machine, which instance is that? Okay, this is worker 01, which is 172.31.71.210. And earlier when I install it, I install the control plane on the worker node. You see, so there is a naming convention mismatch. So we have master running on both the nodes, and so I cannot join that node. So let me do one thing. Let me just quickly change the names over here. Okay, this has to be master now, because in this node I have installed the control plane. Okay, and this has to be worker 1. Okay, so let's go inside this machine. Worker 01 is, let me verify it one more time. My master is 71.210. This is good. And let's go back to this. Now let me run the command over here. Kubectl get nodes. It says it's ready. Kubectl get pods. Yeah, everything is up. And so basically these, both of these are same nodes. So let me just close one session and let me do the installation in the worker node actually. So, okay, I'm gonna pause the recording because I have already showed you the step, and I will unpause it when I'm here in this step run on the worker node. Okay, so let me install all the components in the worker node. All right, so I have performed all the other steps. Now let's run the join node command to join the worker node with the master node. Okay, okay, it was here. So let's paste it, and it will run the pre-flight checks, right? It will do the validation, it will do the sanity checks, and it will make sure all the prerequisites are there in place. And then it will join the worker node with the master node. So let's see. In the worker node and control plane node. So that's why the security groups were incorrectly attached as well. So I had to replace the security group with the correct one, right? So if you were doing it by yourself, if you are following along, I'm sure you wouldn't have done the same mistake that I did. But so here we are. I was able to join the worker node with the control plane node after running the kubeadm join command. And if this command is stuck anywhere or it's timing out, that means there is some issue with your security group setup. That means your worker node is not able to reach to your master control plane node. So make sure you check that. And if it is successful, then you will get reply something like this. Okay. And now if we go back to the master control plane node, and if we run kubectl get nodes, you will see that the node has joined the master. We could have changed the node name as well while bootstrapping it, but I did not do it, so it took the default name, but that's okay for now, right? So we have master, which is ready, control plane, which is ready. And if I run kubectl on the worker node, let's say kubectl get pods or node, I will get this reply because it's not able to identify the default kube config. Okay, what we'll do is we'll just copy the default kubeconfig file from etc kubernetes and kubelet.conf or admin.conf. Yeah, let's copy kubelet.conf, and it has to be inside the home directory .cube. Okay, The folder is not present, so let's create a new folder. Sudo mkdir hyphen p, and it's home.cube. Okay, now let's run the command again. It says permission denied, so let's provide the permissions. Chmod hyphen r 775 home.cube. Okay, now let's run it again. Oh, it's not able to find this file for reading. Let's use sudo for copying it. So the source file has the permission issues. So now it's been copied. Now let's run the kubectl command again. Okay, it's still not working. Let's go inside the directory etc Kubernetes and see what all configuration files we have. So we only have kubelet.conf, which I have copied to cd hyphen home slash cube. Okay, and here is the file. And if I run kubectl get nodes hyphen hyphen kube config, so I'm passing the kube config as this file. Okay, it says permission denied. So let's grant this file permission. Sudo chmod 755 kubelet.conf. Okay, and now let's run. Okay, it's again saying permission denied because I'm using the kubelet conf. Okay, so should be admin.conf, but we don't have admin.conf over here, or do we? etc Kubernetes. Yeah, an admin.conf would have been generated, but if it's not there, what you can do is you can copy it from the master node. So I'll just copy my home.cube and then config. This is the file that we need. Okay, let's copy the entire content of this and let's paste that inside .cube, and I'm gonna call it config to make this a default cube config. Okay, folder does not have permissions, so let me do a sudo as well over here. Okay, now the file is saved. Let's give this file permission, sudo chmod 775 to config. And now let's run kubectl command, get nodes, and pass this. Okay, now we are getting reply. The kubectl utility is now able to talk to API server, which is hosted on the control plane node. And now we don't have to even pass this parameter because we have placed the kube config in the default directory. So it should be able to pick it. Yeah, we're getting the reply and we can run any command, get pods, fun a. Okay, everything is running. And the same way we can join another worker node with the cluster. So let me pause the video and do that, and then I'll show you. Okay, it's done. The worker node 2 has also been set and ready. So if we do kubectl get nodes from worker node 2, I'm getting the reply from the API server, and I can see my master node is ready and other two worker nodes are also ready, and they have joined together as a cluster with the master giving instructions to the worker, right? So this is our cluster, and we'll be using the same cluster for the many next videos, because kind cluster that we were using, as I've told you, like it's good for the beginner. So we used it when we started the series so that you don't have to worry about all those things that we have worked on. And now that you have a good understanding of all the control plane components, how it works, what are network add-ons, what are CNI, and so on, all those things, and kubeconfig as well. So now we install cluster using Kubeadm. We'll also be doing one video in which we'll install the cluster with the hard way, like setting everything from scratch. Like in this, we have used Kubeadm tool, which configure all the control plane components, right? but we can also install it manually. Like we can install each binary one by one manually, like for etcd, for API server, for all those things. It's not really been asked in the exam, but it's a good to know kind of thing. If you are a Kubernetes admin, you should know how to download and install the components one by one on each of the nodes. So we'll see if when we'll do it. Okay. So for now, this video was how do we set up the Kubernetes cluster using Kubeadm utility. And let me see if I am forgetting anything in this video. So let's look at have a look at the diagram that we were seeing earlier. Okay. So what we did, a quick recap, we set up 3 virtual machines on cloud. We picked AWS. You can choose any cloud as per your preference. So we specified one node as the master node and 2 nodes at the worker node. Nodes are nothing but the virtual machines. And then we created 2 separate security group, one for admin node or master node and other for the 2 worker nodes. And here are all the port details, like what are ports we have opened, and the details are here as well, right? So these details I will provide in the GitHub repo, don't worry about it. So all the ports that we needed to open between master node and worker nodes, and for user, for client, and so on, right? So based on that, we have opened it, and on the master node and worker node, we disable swap, we updated kernel parameters, we install container runtime, runc, CNI plugin, and then kubeadm, kubelet, and kubectl utilities. And then on the master node, we initialize control plane using kubeadm, and on the worker node, we run Kubeadm join master to join worker node with the master node, and so that they could come up together as a cluster, right? So there is, we are associating our worker node with the master node. And before that, till here, they were just the separate nodes. They were not part of the cluster. They did not have any connectivity between those, right? So they were separate VMs inside your VPC. So with this, it the worker node has joined the master node, and then we installed Calico for this, right? You can use Calico, Cilium. Don't use ViewNet or Flannel, because Flannel has no support for network policies, and ViewNet is really not really updated. So I wouldn't suggest, either go with Cilium or Calico. Okay. And that's it basically. And we performed the same step in worker node 2. And now that we have like the master is up and running, and we also actually we did one more thing. We actually, let me make a note of it. Once it is joined, we actually copy the kube config from master node to worker nodes. Okay, so that our kubectl client will be able to connect with kube API server running in the master node, right? So yeah, these were the steps that we have performed. These were all the firewall rules or security group rules that we have opened. And this is what we have looked as part of the prerequisites. So that's it. That's it about the video. Sorry for the long video. Actually, I made a mistake as well. So make sure you don't do that. And that's it about this video. I hope after following this video, you were able to install Kubernetes cluster using kubeadm utility, and you were able to join your worker nodes with the master nodes. If you are facing any issues, let me know in the comment section below. By the way, this is gonna be a must have for any Kubernetes administrator. So you should know how do we execute all those steps. Plus, there'll be one question in the exam, there'll be one task for you to complete based on this, like whatever we have done so far. So make sure you do the hands-on by yourself, and do not forget to clean up your virtual machines after you're done. Either you can stop it, but if you are aware of cloud, how it works, even though you stop the virtual machines, it will incur some charge unless you are using a free tier. If you are using a free tier, then it's okay. But if you are not using a free tier, it will incur some charge for the storage that it use. It will be minimum, but still. And if you can terminate, you can terminate it, or you can create an AMI. You can package it as a golden image, so that the next time you have to spin up the cluster, you can just spin up the instances using the AMI, and they will already be connected with each other as a cluster, and you don't have to do all the steps every time, right? For now, I will just keep them stopped, right? So that I don't have to do everything once again, and I have some credit, so I'm not worrying about the cost. So yeah, I will stop it. That's all about this video. Thank you so much for watching, and make sure you like the video, comment on it, and share it with the whoever is trying to learn Kubernetes. And I'm sure this will be a great learning experience. And all the details will be there in the GitHub repository. There'll be a task for you to complete in day 27. I guess this was day 27, right? Yeah. So the task for you will be in the day 27 folder of the GitHub repository. Check that out, try to do that, and feel free to reach out if you face any issues. So thank you so much. I will see you soon with the next video.